There is another technique to solving linear equations. It's called solving linear equation systems by addition or elimination. We'll find as we go along, as you get more complex equations, you might find this system actually easier than the substitution method. So let's take an example of how do we do this by addition. The idea is we're going to add these two equations and to eliminate a variable, and then we're left with one variable. Here's an example. We have a system of equations x minus y equals 2 and 2x plus y equals 7. So we want to solve this system using addition, and we can see that if I add these two equations, so we're going to actually add the two equations. If I add the two equations, the y's will eliminate because negative y plus y gives me 0. And so I'm going to add the x's. X plus 2x is going to be 3x. And minus y plus y is going to be 0. And then we're going to have an equal. 2 plus 7 is going to be 9. And then so we have 3x equals 9. And we divide both sides by 3. We get x equals 3. We can see we've come about this answer quite quickly. And so x is equal to 3. And so now we want to find what y is equal to. Well, we substitute this back into one of these equations. I'll take the first equation, x minus y equals 2. So we have x minus y equals 2. But we know x is 3, so rather than putting x here, we'll put 3 minus y equals 2. And a little manipulation, we subtract 3 from both sides. So we get negative y equals negative 1, or y equals to 1. So y is equal to 1. So there's our solution. Y is 1, x is 3, in other words, the point 3, 1. And of course you should check to make sure that this solution satisfies both equations. If you check quickly, you would get 3 minus 1 is 2, and then 2 times 3 is 6, plus 1 is 7. So it does check. Let's take another example. Okay, here's another system of equations. We're going to solve it by addition. We have 15x plus 2y equals 1, and 2x plus y equals negative 5. So we want to solve this system of equations. We can't just straight add this because nothing will be eliminated. The idea of adding is to eliminate a variable. But we can manipulate it so that when we do add it, something's eliminated. I can see if I multiply this second equation by 2, or more specifically negative 2, I'd get the negative 2y, and when I added that to 2y, we get a 0. So what we're going to do is we're going to take equation 2, and we're going to multiply it by negative 2. So if we do that, equation 2 times negative 2, we'll get negative 2 times 2x is negative 4x, negative 2 times y is negative 2y, equals negative 2 times negative 5 is 10. So this is actually equation 2. It's just multiplied by negative 2. And we just bring down equation 1 now. We bring down equation 1, we'll get 15x plus 2y equals 1. And now I can see if I add these two, the y's will eliminate. Negative 4x plus 15x is 11x. Negative 2y plus 2y is 0. 10 plus 1 is 11. And so we end up as x equal to, we divide both sides by 11, we get 1. X equals to 1. Now I need to find out what y is, so I have to substitute this back in to one of my equations. So I might substitute it into equation 2. If we substitute this into equation 2, x equals 1, we get 2 times 1 plus y equals negative 5. And 2 times 1 is 2. 2 plus y equals 5, negative 5. And then we subtract 2 from both sides. So we get y equal to negative 5, negative 2 is negative 7. Here's my other solution. So my solution is the point 1, negative 7. And that's a method of addition or elimination to find the solution. So it seems like it's a little bit quicker than the previous method, most of the time, not always. but it's one more method of finding solution. Of course, you should check this solution again back into your equations to make sure it satisfies each equation. And you can also graph this and find the solution, solve each one for y, and find the intersection to verify that this is the actual intersection. One more example. We're going to solve this system using addition method. We have 2x plus 4y equals 2, equation 1, and 3x minus 5y equals negative 8, equation 2. And what we want to do is multiply both equations in this case by numbers in order to make one of the coefficients the additive inverse of the other one. In other words, I can see that this equation, if I multiply it by 3, I get a 6 here. And this equation, if I multiply by negative 2, I get a negative 6 here. And you have to see that by inspection. You have to look for that when you look at your equations. So what are we going to do? We're going to take equation 1 times 3. And if we do equation 1 times 3, what do we end up with? 3 times 2x is 6x. 3 times 4y is 12y. And 3 times 2 is 6. So that's my equation 1, rewritten. Then we're going to take equation 2 and multiply it by negative 2. So equation 2 times negative 2. If we do equation 2 times negative 2, what we end up with is negative 2 times 3x, negative 6x. Negative 2 times negative 5y is 10y, plus 10y. Negative 2 times negative 8 is 16. And that's equation 2. And now we can add these two and eliminate. So if we add these two and eliminate, we get 6x minus 6x gives me 0. That's what we want. 12y plus 10y is 22y equals 6 plus 16 is 22. And we divide by 22 both sides, we get y equal to 1. So we have part of the solution is y equals to 1. We need to figure out x. And in order to figure out x, you have to substitute this number into one of the equations and solve for x. I'm going to do equation 1. So we get 2x plus 4 times 1 equals 2. And 2x plus 4 equals 2. Subtract 4 from both sides, we get 2x equals negative 2. And divide by 2, we get x equal negative 1. So there's my other solution, negative 1. And so the point negative 1, 1 is where these two lines intersect. Again, you want to check that in your system. If we check it in the first equation, we'll get negative 2 plus 4 is 2. That's true. And here we'll get negative 3 minus 5 gives you negative 8. That's true too. So we know by checking this is the solution. And again, you can graph that.